Okay, so we have two forces acting on this car. One force is 380 newtons at a 30-degree angle. The other force is 450 at 10 degrees. The first question is, what is the resultant of these two forces? So this is vector addition. We're going to take these two vectors, simplify the two vectors into one. So let's just look at it like this. So here's the car, right? So the 380 Newton force is going like that. So we'll label this 380 newtons. Now they give us the angle off the vertical. See this right here? They give us this angle off the vertical. I like angles off the horizontal. So I'm going to say this angle right here. So if this is 30, what would this be in here? 60. That's not really drawn to scale too well, but whatever. We'll be punching this in our calculator, so it doesn't matter. So 30 degrees off the vertical is the same as 60 degrees off the horizontal. Okay, our 450 Newton force is pointing this way. So we'll label this guy 450 newtons, and it's 10 degrees off the vertical. So what would that angle be off the horizontal? 80. Okay? Because the two have to add up to 90. All right? So we need to break these two forces, x component, y component. We need to break the 380 and the 450 into their component vectors. So I'm going to show those here. So this represents the x component of the 380. This represents the y component of the 380. So these components, you use trig. So I'll show you how to do like this guy right here. How do you get the x component of the 380? This is going to be cosine 60 times 380. And then what's this guy going to be? Sine 60 times 380. All right? So when you punch this in, you're going to get this guy right here should be 329.1 newtons. And then the x component should be 190 newtons. Now, sign conventions. Our sign convention is to the right is plus, to the left is minus, up plus, down minus, like that. So this is going to be positive because it points to the right. And then this guy is going to be positive because it points up. Okay, now let's do the 450. The 450 has x component. There's an x component, and there is a y component, like that. So the x component, you're going to do cosine 80 times 450. This guy works out to be 78.14. But he's negative. Why is this guy negative? Because which way does he point? To the left. So you got to make him negative. And then this y component of the 450 is 443.2. 443.2. And positive because it points up. So the next step is when you're doing vector addition is you got to sum up your x vectors, sum up your y vectors. So how many x vectors do we have here? 1 and 2. There are 2 x vectors. So you add them up, you're going to go 190 minus the 78.14. So your total x comes out as positive 111.86. And then the y, we have 2 y vectors. We got this guy, and we have this guy. So this is going to be 329.1 plus 443.2. And then this gives an answer of 772.3 positive. So we're almost done. Now, shrink this down. So the next thing, what do we do once we have total x and total y? We have our total x and our total y. Tip to tail. Let me draw these in. So our total x points to the right because it's positive, 111.86. our total y is also positive and much bigger, right? And it's not important that this is perfect. Notice these should be scaled somewhat. 772.3, but actually this would actually need to be way longer, right? Like 7 times longer. But that's close enough. And then our resultant vector is what we're looking for. So we're looking for this resultant vector, which is the hypotenuse. So how do we get that resultant vector? You do Pythagorean theorem, and it comes out as 780. 780 newtons, but that's only half the answer. What's the other half of the answer? The angle. So you got to calculate the angle because this is a vector and it has direction. So you calculate what that angle is using trig. You go tangent inverse 772.3 over 111.86. So this gives an angle of about 8 degrees, which you would want to say, so these two forces simplify to this, where this is 8 degrees. How would you describe that? 8 degrees how? Well, what the textbook says, it says 8 degrees to the right of forward. 8 degrees to the right of forward. Okay? Now, part B is super fast. So we've figured out that the net force on this car, what we did is we've taken the two forces acting on the car and we've simplified them. So this is the net force. The net force is 780 newtons at an angle of 8 degrees. If you know the net force, how do you find the acceleration? Part B wants us to find the acceleration. What is net force always equal to? ma. So they give us the m right here. The mass is 3,200. So therefore, the acceleration is going to be the net force over the mass. So we're going to go 780 newtons divided by 3,200 kilograms. And that simplifies to give 0.24 meter per second squared. Now, which way is that acceleration directed? Which way is this acceleration directed? At 8 degrees, it's going to be in the same direction as the net force. Never, ever, ever will an object accelerate in a direction other than the direction of the net force. Net force and acceleration are always together.